This is the last objective for Unit 11. It's Objective 5. And all of Unit 11 up until now has been polar graphing. But the last objective is simplifying messy algebraic expressions. That is something that you will definitely encounter in calculus, and we need to be able to deal with it effectively and efficiently and accurately. Now these methods that I'm going to be showing you, I mean, you've actually seen before, so it's not like it's new stuff. It's just we need to practice it. Okay, so this first problem here, we've got a complex fraction because there's a fraction within a fraction, so it's never okay to leave something like that. Now, I'm noticing that inside the radicals I've got 4x minus 1s, and then my denominator down here is really close to that. In fact, it's opposite of that. It's definitely to our advantage to go ahead and clean that up just a little bit right there first, so that it's the same as the stuff inside the radicals. So we can factor out a GCF of -1, and the 4x would become positive, and the 1 would become negative. Now we want to take the -1, get it out of the denominator, and we're going to move it to the numerator and distribute. So our denominator here is 4x minus 1, and it's a quantity to the first power. Up here now, because the signs are switching, I think I'm going to move the fraction out front. So 7 over square root of 4x minus 1 minus 3 times the square root of 4x minus 1. And I don't need parentheses right there. Okay. So now, the complex fraction bit. We need to get rid of the extra fraction within the fraction. This is something we have shown you. So what would I need to clear the fractions? Well, if I multiply top and bottom by root 4x minus 1, and if it helps, you can do the over 1 and over 1 thing. Okay, now the denominator, notice I have 4x minus 1 to the first, and 4x minus 1 inside a square root. Now, square root is a 1/2 power. So I really have 4x minus 1 to the first times 4x minus 1 to the 1/2, which would give me 4x minus 1 quantity to the 3/2, because we add the exponents. Now, up here in the numerator, we actually have to multiply, we have to distribute first, and then reduce, even though we're doing it all in one step. So when I multiply the first fraction by the root 4x minus 1, the root 4x minus 1 is reduced, and we're left with 7. And now when I multiply the second one, here's the minus already. I have 3 times root 4x minus 1 times root 4x minus 1. Now, root 4x minus 1 times root 4x minus 1, that's a pair for square roots, and pairs come out, or 4x minus 1 quantity to the 1/2 times 4x minus 1 quantity to the 1/2, add the exponents, it's 4x minus 1 to the first. So anyway, we have 3 times 4x minus 1 to the first. We don't have to write the first power. Now, some of you perhaps might be tempted. You see the 4x minus 1s you want to reduce. Do not reduce here. The numerator is not in factored form. You do not reduce unless you're in factored form. The numerator has a minus up there in between. So, can we factor something out and clean it up more? Well, we can at least distribute. And combine like terms. So we have 10 minus 12x over 4x minus 1 quantity to 3/2. Now the numerator does factor. There's a GCF of 2. So the numerator is in factored form now. Now, do we have any common factors? No. So what's the correct answer? Well, it could be this way, where the numerator is not factored, or you could have the numerator written like this. Okay, and so really it's one of those two ways. That's really about all you can do. It is true that we have a radical in the denominator, but as I've been mentioning to you recently, we don't worry too much about radicals in the denominator. Now, we still need to be able to rationalize if necessary, but this one actually gets messier if you rationalize the denominator. So let's try number 2. And we're looking at this, and we'll be saying, okay, well, what's the big deal? Well, there's a negative exponent here. And that negative exponent is really telling us this is like 7x over 2x plus 3 quantity to the 1/4. So this part right here is really making this whole expression a complex fraction. Okay, so now if it helps you, you can rewrite it, and you could write that fraction right there. Or we can just realize what's going on, and we could multiply top and bottom to clear the complex fraction bit. Now to do that, I'd need to multiply top and bottom by 2x plus 3 quantity to the 1/4. And again, you don't have to do the over ones, but I think it's helpful for some of you. Okay, now if we do the denominator first, we notice we have 2x plus 3 quantity to the second and 2x plus 3 quantity to the 1/4. The values inside the parentheses are the same. So we can add the exponents since we're multiplying. 2 plus 1/4 is 2 1/4. It's also known as 9/4, and that's the way we should write it. Now if we distribute to the numerator, so I have 5 times 2x plus 3 to the 3/4 times 2x plus 3 to the 1/4. I add the exponents on those like terms since I'm multiplying. And 3/4 plus 1/4 is 1, so I have 5 times 2x plus 3 to the first. Okay, now when I'm multiplying by the second one, remember it's really like we're multiplying the fraction, and so the 2x plus 3 to the 1/4 reduce, leaving us with just plus 7x. Okay, now again, much like the last one, we're not in factored form in the numerator, so do not try to reduce the 2x plus 3's right now. You do not reduce unless you're in factored form. So we can distribute 5, so 10x plus 15 plus 7x all over 2x plus 3 quantity to the 9/4. And we can combine like terms. And so we can get 17x plus 15, which, by the way, does not factor in any way. And so since there are no common terms, since the numerator has to be thought of as a quantity, really, that's the final answer right there, 17x plus 15 all over 2x plus 3 quantity to the 9/4. Okay, moving on, number 3. Now, in the previous problems, they were already fractions to begin with. Now, we could get fractions because notice I have x squared plus 1 to the negative 4 power, so that's really 1 over x squared plus 1. And the things that have positive exponents would be in the numerator. And I have x squared plus 1 quantity to the negative 3, and so that's 1 over x squared plus 1 quantity to the third times the 2 times x plus 1, so that part would be in the numerator. Now that's one way to do it. However, I would tell you the more efficient way is probably to just try to factor what's going on here. So there's GCF stuff going on. Okay, so we have x squared plus 1. Sorry, I have x plus 1 here, and I have x plus 1 over here. So we have x plus 1's in common. Okay, now how many of them do we have? We have 1 in common to the both of them. Okay, so x plus 1, just one of them in common. Okay, now what else do we have? We also have x squared plus 1's in common. Now, with negative exponents, it's kind of very different from when we're dealing with the positive exponent things. With negative exponent things, you want to bring out as much negative exponent as you possibly can so that there's no negative exponents left behind. So in that case, then, the bigger one would be the x squared plus 1 to the negative 4 power. So bring out the bigger one. There. Okay, now, is there anything else in common? Yes, we also have a 2 in common as well. Okay, so there is a 2 in common in both parts, and so we'll put that out in front. Okay, now what's left behind? Okay, well, I've already got the 2, and there's an x and a negative 3, so negative 3x. Now, I've also pulled out as much of the negative exponent, so x squared plus 1 quantity to the negative 4, that's already pulled out, so I don't need any x squared plus 1 there. I only have one x plus 1, so I would have an x plus 1 here, so that I get a total of x plus 1 quantity squared. Okay, plus, okay, I have the GCF of 2, I have the x plus 1. Okay, now, I have x squared plus 1 quantity to the negative 4 out front, and I only want x squared plus 1 quantity to the negative 3 right there. So wouldn't that mean I would need x squared plus 1 to the positive 1 power, so that if I add the exponents, I have negative 3? Yes. Okay, so now out front, we have 2 times x plus 1 times x squared plus 1 to the negative 4. And in here, inside the square brackets, if I distribute a negative 3x, and there's a positive 1 exponent on this, so that if we distribute a positive 1, we just get plus x squared plus 1. And so if we combine like terms, we get negative 3x squared plus x squared. So negative 2x squared. And we get minus 3x and plus 1. Okay, and that's pretty much what we can do. Now, we could move the x squared plus 1 quantity to the negative 4th. We could move it to the denominator. It would become a positive 4 exponent in that case. We also try to do the fewest number of negatives possible. So I notice there's 2 negatives inside the parentheses right here. We could factor out the GCF of negative 1. So bring it all the way out in front, negative 2 x plus 1 times x squared plus 1 to the negative 4. And so all my signs would change in that last set of parentheses. So positive 2x squared plus 3x minus 1. So really they're about the same. So we'll just go ahead and say or. Maybe the bottom one's a little bit nicer, but that's about the best you can do right there. Okay, moving on. Number 4. Kind of similar to the last one, except for the fact that this one's already a big fraction. And now I'm noticing lots of 5x plus 1s. Okay, now, yes, there is kind of a shortcut thing here. If you really understand it, you just got to be careful. The top is not in factored form. There's a minus in between, and so the top is not in factored form. Safest way to do this, factor the numerator. So I notice there's a GCF of 5x plus 1 and 5 of them in common to the numerator. So 5x plus 1 to the 5th. Okay, and I also see an x in common as well in the numerator. So x. Okay, now what's left behind? Okay, well, we've got 2 times 3x plus 1 minus, okay, now I had 3 and a 7, so 3 times 7, 21. And we have one more 5x plus 1 left behind, so that if we multiplied the GCF stuff out in front, we would have a 5x plus 1 quantity to the 6th. Okay, so 5x plus 1 quantity to the 8th. Okay, now, we're in factored form. It's not all the way cleaned up, but we're in factored form, and I notice 5x plus 1 to the 5th in the numerator, 5x plus 1 to the 8th in the denominator. So 5 of those would reduce with 5 of those in the denominator. So I'm left with 5x plus 1 quantity to the 3rd in the denominator. Let's see, also, if we distribute the 2, and if I distribute the negative 21, I get 6x plus 2 minus 105x minus 21. Okay. So we've got numerator, don't forget the GCF of x. Okay, 6x minus 105x, that's negative 99x. 2 minus 21, that's negative 19. And 5x plus 1 quantity to the 3rd. Okay, now that I've got it like this, I notice that there's a negative in both spots there in the numerator, and so really we should pull out that GCF of negative. So negative x times 99x plus 19 all over 5x plus 1 quantity to the 3rd. That really is, you need to pull out that negative because we get fewer negatives that way. That really is the most cleaned up version of it all. Okay. You could also write it like this. And I know I've shown you guys this before. You could bring the negative and just kind of line it up with the fraction bar. And you could actually distribute the x then. And you could have 99x squared plus 19x. And then 5x plus 1 quantity to the 3rd. And that one's actually nice too, because we don't have the parentheses in the numerator and yet just the one negative, and it's lined up with the fraction bar, meaning that the whole fraction is negative, meaning that you would distribute that negative to the numerator. Okay, one last problem. We've done some really messy ones, and this one's actually not that bad. It's just sometimes when I do the really messy ones, and then there's a few like this in the assignment, some students will think that they're really hard because I didn't show any examples like this, and so I figure I should probably show an example like this. So here we go. Really all we're doing is just combining these two terms into a single fraction. And so let's realize the denominator right here is 1 right now. And yes, I know there's a radical in the denominator here, but you know, as I already mentioned, that doesn't bother us so much. If we need to rationalize the denominator, we can, but to get a common denominator, I just need to multiply top and bottom of the fraction here on the left by that denominator. So I'm going to multiply by root 5 minus x to the top bottom. And what do we notice? Well, now we have the common denominator of root 5 minus x. But over here on the left, root 5 minus x times root 5 minus x, I've got a pair, and so the pairs come out, and I'm left with 5 minus x. 5 minus x. Okay, and then minus, and I need to distribute that minus over here. Minus 7 plus 4x. Okay, so we've got root 5 minus x, and okay, so I've got 5 minus 7, so negative 2, and negative x plus 4x, so plus 3x, and it's nice to put the positive thing out in front there in the numerator. So 3x minus 2 over root 5 minus